Students. So let's continue with the problems. The second exercise. First question. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So the solid is a cone, okay, which is standing on top of a hemisphere, or we can say a cone is mounted on a hemisphere, something like this. Okay, here according to the question, the radius is given as the radii being equal to 1 centimeter and the height is equal to the radius, so the height will also become 1 centimeter. Height of the cone is equal to the radius, so height is 1 centimeter. What we have to find is the volume of the solid. So here the solid is made up of cone and hemisphere, right? So therefore volume of the solid will be equal to, it is the combined volume, isn't it? That is volume of cone, whatever this cone has occupied the space, that space plus the space occupied by the hemisphere, both together. Okay, volume of cone plus volume of hemisphere. Okay, now volume of cone is given by the formula 1 by 3 pi r square h, isn't it? And volume of hemisphere is given by 2 by 3 pi r cube. Now between these two terms, what is common? 1 by 3 pi r square is common. Okay, so 3 is in the denominator, 3 is in the denominator, so you can take 3 as common in the denominator. Pi and pi, between r square and r cube, you must take the least power, that is r square. So what is left out? H plus the numerator 2 is left out and one more r. Okay, now let's not substitute the value of pi because we need the answer in terms of pi. So let's keep pi as it is. What is the value of r? It is 1 square. And what is the value of h? It is 1 plus 2. What is the value of r? That is also 1. Now in the next line, 1 by 3 pi, 1 square is 1. Okay, 1 plus 2 into 1 is 2. 1 plus 2 is 3. Okay, so this 3 and this 3 gets cancelled. So pi into 1 is pi. Therefore, it is pi centimeter cube. That's the volume of the solid that is required. Okay, so let's get into the next question. In the next question, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. Okay, the diameter of the model is 3 centimeter. So let's write it down. So the diameter is 3 centimeter, which implies the radius will become 3 by 2 centimeter. Okay, and the total length of the model is 12 centimeter and the height of the cone, okay, let me take it as HC, where HC is the height of the cone and it is given as 2 centimeter. Okay, now most of the time when we are finding the surface area, we don't take the height of the cone into consideration, but in volume we need height of cone, so that's why I've taken HC. Okay, because the cylinder will also have its own height. Okay, so let's draw the figure. What we have got is a cylinder. Okay, for this cylinder, two cones of same dimensions. Okay, two cones of same dimensions, something like this. This is how the model is. Okay, we've attached two cones. Okay, the height of the cone is given as 2 centimeter, that is from here to here. This is 2 centimeter. Similarly, the other side, this is 2 centimeter. And if you read the question, they have given the total length of the model to be 12 centimeter. 12 centimeter is the total length of the model, which clearly says that the height of the cylinder will be how much? 8 centimeter, isn't it? Left side 2 centimeter, right side 2 centimeter if you leave it. So total the left out height will be the height of the cylinder, that is 8 centimeter. Okay, HCY, height of the cylinder is 8 centimeter. meter. Okay. Now, what should we find? We have to find the air contained in the model. Okay. Now, the amount of air that is inside the model, that is actually equal to the volume of the model, isn't it? Whatever this model, how much ever space it has occupied, okay, the air inside it is also occupied the same space, and they have clearly mentioned that it is made up of thin aluminum sheet. Okay, so the volume of air inside the model and the volume of the model doesn't make a big difference. Okay, to understand this better, let's take a cylindrical bucket. Let's say this is a cylindrical bucket and you're storing water in this. Okay, now the question is, what is the volume of this water inside the bucket? Okay, what is the volume of the water? That is actually equal to the volume of the cylinder, isn't it? Imagine a cylinder like this, a solid cylinder of the same dimension. Okay, whatever the cylinder occupies, the water inside will also occupy the same amount of space, isn't it? So the volume of water or the volume of air inside any particular model is equal to the volume of the model itself, provided that the thickness is very less. Okay, that is, it is thin. Suppose if you have got a bucket like this, let's say a bucket in this manner, okay, a cylindrical bucket, something like this. Let's say we have got a cylindrical bucket, okay, like this. Okay, now this is the place that is provided to store water. Here, if I ask you what is the volume of water inside the model, remember here we are not supposed to take the outside cylinder. Volume of outside cylinder will not give you the volume of water, because here in this place, do we store water? No, it's a material, right? All these are material. Okay, what is the volume of water? That will be equal to the volume of the smaller cylinder that is inside. Okay, because that is where the water is, isn't it? So you have to be very careful. Here the thickness is more, so you cannot consider the volume of outer cylinder to be the volume of water. That is wrong. Okay, whenever the thickness is very small, then you can consider volume of cylinder is equal to volume of the water. Okay, volume of the model will be equal to the volume of air contained. Okay, so let me write it here. Volume of air contained, volume of air contained in the model, that will be equal to, there are two cones, so 2 times volume of cone plus volume of cylinder. What is volume of cone? 2 into volume of cone is given by 1/3 pi r square. We have to write it as h, but I'll write it as hc because height of the cone we have taken it as hc. Okay, plus volume of cylinder is pi r square hcy. Okay, now what is common here? If you observe carefully, pi r square is common. Now what is left out? 2 into 1/3 is 2/3. hc is left out, and here hcy is left out. Okay, and the next step, let's substitute the values. Okay, so let's substitute the values. What is the value of pi? The value of pi is 22/7. And what is the value of radius? The radius is 3/2, if I'm not wrong. Yes, 3/2 whole square. 2/3. Height of the cone is 2 plus height of the cylinder is 8. Okay, so 22/7 into 3/2 the whole square is 9/4. This becomes 4/3 plus 8. Okay, and let's simplify this. So 22/7 plus 22/7 into 9/4. If you take LCM, it becomes this 8 can be 8/1. The LCM will be shortcut method, 3 into 1. Multiply the denominators. 3 into 1 is 3. Then crisscross. 4 into 1 is 4. 8 3s are 24. Okay, let me solve the next step here. So you get 22/7 into 9/4 into 4 plus 24 is 28 divided by 3. So 4 1s are 4, 7s are, again 7 and 7 gets cancelled. 3 1s are 3, 3s are. So 22 into 3 is 66. Therefore, the air contained in the model is 66 centimeter cube. Okay. So we have to draw the model, and based on the model, we will be finding the volume. Okay. Now let's come to the next question. The next question, a gulab jamun contains sugar syrup up to about 30% of its volume. Whatever is the volume of the jamun, in that the 30% is syrup itself. Okay. 30% of the volume is occupied by the syrup. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends, with length 5 centimeter and diameter 2.8 centimeter. So let me redraw the shape of the gulab jamun. It is something like a cylinder with hemispherical ends, something like this. Okay, it is also given inside the jar, isn't it? Something like this. Now, the total length is given as 5 centimeter. Okay. Now, and the diameter, okay, that is this length. The diameter is 2.8. So the radius will become 1.4. So this length is also 1.4 and this length is also 1.4, isn't it? So the height of the cylinder will become how much? In 5 centimeter, 1.4 and 1.4. If you take it out, 5 minus 2.8, which becomes 2.2. Okay. So the height of the cylinder is 2.2 centimeter. So let me write it here. The height of the cylinder is 2.2 centimeter. Now, what is given in the question? Clearly in the question, it is given the volume of syrup is given. Okay, that is equal to 30% of volume of jamun. Whatever is the volume of jamun, in that the 30% is the syrup itself. Now, this is for volume of syrup in 1 jamun, isn't it? This is for 1 jamun. Now, what we have to find is volume of syrup in 45 jamun, isn't it? So, volume of syrup in 45 jamuns. That is equal to, just multiply 45. This is for 1 jamun. If you want for 45 jamuns, we have to multiply by 45, isn't it? For example, 1 pen is 10 rupees. 5 pen is how much? You'll simply multiply 5 and 10, right? Same logic. 1 jamun, so much. 45 jamuns, how much? In the sense, you have to multiply by 45. So 45 into 30% of volume of 1 jamun. Okay. Volume of 1 jamun. Now, 45 into 30% can be written as 30 by 100. Okay. What is the volume of 1 jamun? How do we calculate? Look at the figure. The volume of 1 jamun is actually equal to volume of 1 cylinder and volume of 2 hemisphere, isn't it? So volume of VOL, volume of cylinder plus 2 times volume of hemisphere. Okay. So here 0, 0 gets cancelled. 5 2s are 5 9s are. So this becomes 9 into 3 by 2. Volume of cylinder is given by the formula pi r square h. And the volume of hemisphere 2 into 2 by 3 pi r cube. Okay, that's the formula. So it becomes 9. 9 3s are 27, right? So 27 by 2. Here again, in both the terms, pi r square is common. So I'll take pi r square outside. So what is left out? H plus 2 into 2 is 4. 4 by 3 r. Okay. Before solving, always try to take common. Okay. So 27 by 2. Pi value is 22 by 7. And the radius is 1.4 square because the diameter is 2.8 centimeter. The height of the cylindrical part is 2.2. plus 4 by 3 into R. R is how much? 1.4. Okay. So 2 ones are 2, 11s are. So it becomes 27 into 11 by 7. 1.4, the whole square can be as 1.4 into 1.4. 2.2 as it is. 4 into 1.4 becomes 5.6 by 3. Okay. So here also you can cancel 7 ones are 7.2s are. Okay. So let me continue. Let me continue here. So let me continue. 27 into 11 into 0.2 into 1.4. Okay. Here we must take LCM. Okay. This can be written as 2.2 by 1. So multiply the denominator. 3 into 1 is 3. 2 point into 3 is 6.6 plus 5.6. Okay. So this becomes 27 into 11 into 0.2 into 1.4 into 6.6 plus 5.6. That becomes 12.2, isn't it? By 3. So 3 ones are 3 nines are. So what we are left is 9 into 11 into 0 0.2 into 1.4 into 12.2. So if you multiply all this, 9 into 11 is 99 into 0.28. So I've just multiplied these two. 0.2 into 1.4. 14 twos are 28. So after two numbers, we have to place a decimal. 0.28 into 12.2. So multiply all the stuff, you will get the answer. So let me make use of the calculator and tell you the answer. 99 into 0.28 into 12.2. That will give you around 338.184 centimeter cube. That is the volume of the syrup. Okay, that is the volume of the syrup in 45 jamuns. So let me recall this. So volume of syrup is given as 30% of volume of 1 jamun. So in 45 jamuns, we have to just multiply by 45. And how do we calculate volume of 1 jamun? It is volume of cylinder plus 2 times volume of hemisphere, because it is made up of 2 hemispheres and 1 cylinder. And we substituted the formula. After substituting the formula, take out the common factors. Once we take out the common factors, we must substitute the values and simplify it. On simplification, we got it as 338.184 centimeter cube. So let's get into the next question. So in the next question, we have got a pen stand made up of wood. Okay, a pen stand made up of wood is in the shape of a cuboid with 4 conical depressions to hold pens. So as you can see here, okay, the radius of each depression is 0.5 centimeter and depth is 1.4. So, and the dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. Find the volume of the wood in the entire stand. So here we have to find the volume of the wood. Okay, so let's find the volume of the wood. Let's take the capital L, capital B, and capital H are the length, breadth, and the height of the cuboid. That is 15 centimeter, 10 centimeter, and 3.5 centimeter. Okay, and small r is the radius of the cone, which is 3.5 centimeter, and the depth is the small h, that is the height of the cone, which is 1.4 centimeter. So this depth, as you can see, I'm marking it. Okay, from here to here, this depth is 1.4. Okay, now what we have to calculate is, we have to calculate volume of the wood. Okay, volume of wood in pen stand. What we'll do is, let's find the volume of the cuboid. Okay, volume of cuboid. Okay, now wherever this conical depressions are there, in this part we don't have wood, right? Wood is not there. When I say volume of cuboid, the entire volume comes. But here the four conical parts, okay, depressions, here we don't have wood. So which means we must subtract it. So minus 4 times whatever the volume of cone, okay, volume of cone. So volume of cuboid is given by the formula L into B into H, capital L into capital B into capital H, minus 4 into volume of cone is 1 by 3 pi small r square small h. Okay. So L is 15 into 10 into 3.5 minus 4 into 1 by 3, pi value is 22 by 7, r square, the radius is 3.5, the whole square, so which can be written as 3.5 into 3.5 into h. The height is 1.4 centimeter. Okay. So according to the given part, we have written it. So here 3.5 ones are, 3.5 twos are, 2 ones are, 2 11s are. Let's write out the left out thing. Okay. So 15 into 10 is 150, or let's multiply 10 and 3.5. That will give you 35. So 15 into 35 minus 4 into 1 by 3 is 4 by 3 into 11 into 3.5 into 1.4. Okay. So 15 into 35. So 350, 35 into 5. 175, 12, 525. Okay. So we get it as 525 minus, here let's multiply 4 into 11 is 44, 44 into 3.5 into 1.4. Let's do that. So 44 into 3.5 into 1.4 and divided by 3. Okay. So we get it as 71.866. Keeps on going. Let's check the data once. Okay, here I made a small mistake. The radius of the conical depressions is 0.5 centimeter. Okay. So let's change here. 0.5 into 0. Let me rewrite it again. Okay. So this is what happens. We have to be very careful when we solve it. Such mistake if happens in exam, we'll lose marks. So 0.5 into 0.5, h is 1.4. So we can cancel 7 ones are 7.2s are. So it will become 4 by 3 into 22 into 0.5 into 0.5 into 0.2. Now observe carefully. 22 into 0.5 will become 11. 0.5 into 0.2 will become 0.1. Okay, 0.01. Okay. So 22 into 0.5 is 11. 0.5 into 0.2 is 0.1. So this will become 525 minus 11 into 0.1 is 1.1. 1.1 into 4 is 4.4. So this becomes 4.4 by 3. So 525 minus 4.4 by 3. So it becomes 1.4. So 3 ones are 3, 3 ones are 3, 1 carry, it becomes 14, 3 fours are 12. Okay. 2 is the remainder. If you place a decimal, it becomes 20. 3 6 are 18. So it keeps going 4, 4, 6, 6, 6. Let me take it as 4, 6, 7. So if you simplify this, you get around 4, 5, 23 point 54 something. Okay. So much centimeter cube. That will be the answer. So again, this is a very, very simple one. What we did was we found the volume of the cuboid. So we got the entire thing, but here we have 4 conical depressions where the wood is not there. In this conical depressions, we don't have any wood, so we must subtract it. So that's why we subtracted it. So we have solved 4 sums. The remaining 4 sums we will discuss in the next video. Thank you, students.